So a pyramid with a square base or an equilateral triangle has congruent triangles for their faces. So an equilateral triangle on the bottom, those are going to have congruent faces. All right, that's just saying that if it's going to have the same bottom, if you were doing the base, if you were trying to find the area of this front-facing triangle right here, then it's going to be the same. That would be the same as this face of the triangle over here because it has the same base, and it would be the same as the triangle in the back. Because you guys would be amazed that it changes. So that it would be the same. The red, the blue, and the yellow sides are all going to be congruent. And on the one on the left, they're all going to be congruent as well. Now, the height of it is not from the height of the middle of the pyramid, because who cares what's inside the pyramid? We're talking about surface area, right? We don't care if there's a pharaoh in there. We just want to know how much it costs to paint the replica. Except when we're talking surface area. Actually, I love it. It's inside that counts, unless it's surface area. Like People magazine, all like the most beautiful people? No, that's what's on the outside, I guess. Because somebody says, hey, this person. The surface area of a pyramid is the sum of the areas of its base and its lateral faces. Find the surface area of the pyramid below. So as we know, the base of this is going to be 14 times 14 because it's an equilateral, as it said. It's an equilateral square. So it's side times side. So our base is going to be 14 times 14, which equals what? Yes. 196. So I have 196 units squared. That is how much my base is. Then we have to find out the area of each side. And since they're all the same, I'm going to take 1/2 base times height. The base is 14. The height is 25. So I have 25 times 7, which is simple because that's just like 7 quarters, right? Because 8 quarters would be $2. So 7 quarters is $1.75. So that is how much one side is of this. But there's more than just one side. There's 4 sides, so we have to multiply it by 4, and that's where this comes from. And we're doing that because we're recognizing that it's an equilateral square pyramid. Someone, yes, Jermichael.
I was thinking about like 25 and stuff for a second quarter. I don't think 4 quarters is $1.
Uh-huh.
So, like emergency, would you rather have 8 quarters or $2? I mean, like, would you ever have it in change form or dollar form?
An emergency. Right, exactly. Or if you need to pay for parking and might not take dollars, yeah. It's a good point. I would say quarters. They're easy to carry, too. What you got, Caitlin? Can you repeat that? 700 even? So that's 2 different people that said that? Good. 700 even. And we have to add them two together, those two together. 196 plus 700 is equal to 896 units squared. Yes. Yep. Wait until we get through this one before you do that, okay? Now we have find the surface area of a triangular pyramid below. This pyramid is different than the one that you have on your page, so I would like you to please update your pyramid that you have to look like this. Don't worry about how tall it is. Don't worry about how tall it is. Just Yours is very similar to that, but it gives you one more measurement. People are such scrunchy faces. Update the information you have with that. No, I did not know how to do it. That's not mathematically correct. Didn't know how to do it.
Well, I mean, like you didn't.
Yeah, well, because it was not mathematically correct. Yes. You don't have to redraw it. Just update those distances. You don't have to redraw the triangle, people. I didn't tell you to redraw the triangle. I said to update the lengths. I didn't say to redraw the triangle. It's just taller. Visually. I'll show you on the. I'll try to figure out if I can do. Yeah. So we can do 5. Oops. Nope, ain't nobody got time for that. So those are all congruent on the bottom there at 5 inches. The reason why I covered that other one up is because you didn't have this distance here, which is 4.3. Okay, you didn't have that distance, so we haven't taught you Pythagorean theorem yet. So, okay, you got that copy down? We're going to move along. Yes. No. Do you see 10 centimeters here? No. We're updating it completely. That one is not mathematically possible. And for those of you that are done copying, I'll explain why to the one that's originally in your notes is not mathematically possible. You cannot have an equilateral triangle where this is 10 inches when those are all 6 inches. That's not possible. No, it's physically not. Does not happen. Not in our three-dimensional world. Not in a two-dimensional world either. Okay. So we've got that established, so let's get to it now. If I could get this to erase. Thank you. All right. So now in order to find this, I'm going to find the area of the base. And with the old triangle that was on there, you couldn't figure that out because it didn't have how the length times width to do a half for base times height. So on the floor, this is the floor of the pyramid. We have 1/2 base times height, which is going to be 1/2. The base is 5. The height is 4.3. What does that come out to be? No rush. I'm just saying if people are... What you got?
43.
No. You multiplied.
10.75. Yep. Oh, I tend to multiplied it by 2.
Multiplied it by 2. Now we have, once again, it's an equilateral base. So it's an equilateral triangle base. So that means that all 3 of the triangles on top are going to be the same. That's why it says each side is the area 1/2 base times height. And I'm going to go like that to that right now because we're doing it right here. So I have 1/2 base times height. 1/2 base is... What's my base in this situation now? 5, yes. 5. And my height in this situation, my slant height it's called, 9.1. It's 9.1. Remember, the slant height is not from the middle. If I had a triangle, like that, it's not from the middle of the base. It's the one that's lean with it. Okay, it's the one that is leaning over along the side. Okay, is that clear? Okay, so it's leaning with it. It's going to be at an angle on a pyramid. Yes. I do not, because no one was able to get tissues for this classroom because the 8th graders don't have any. So like I said on Friday, if you guys have the extra tissue paper in your activity period, my classroom could really go for some. Yes. So what is 1/2 times 5 times 0.91 or 9.1? Now we have that as one side of it. That doesn't take care of all of them. That only takes care of one face, and we've taken care of one base. How many faces do we have that are the same? 3. So I have, my base is 10.75 inches squared. Then we have to multiply 22.75 inches squared by 3. 68.25. Don't say 25. Unless you say 25 hundredths. 68 and 25 hundredths, that works, but don't say 68 and 25. That's 68 plus the number 25. Yes. Yes. Here is the last example, and here's the homework. So last example there, homework there. So we add those two together, and what do you get? We have 79 inches squared. 79 inches squared. Jamichael. That'd be cool. Bring it tomorrow though? Yeah, cool, thanks. If the base of the measurements are the same as the sides, equilateral, you can multiply the formula for the sides by 4. So that would be a triangle like this. That's too much. So that would be an equilateral triangle like this. That one is an equilateral triangle on every single side. Okay, so you just have to find the amount of 1 and then multiply it by 4. Is that clear? Good. A cone, however, is another 3-dimensional shape. Most of the cones you see have a circular base. The formula for the surface area of a cone is, we know that there's a circular base, and the circular base is going to be pi r squared. That's from 1 week ago today. Oh, how the kids grow up. So we have the area of the base is pi r times the length, or times the, didn't mean to do that. Hold on, sorry. Pi r squared. So to rewrite it, stop talking. 3.14 times the radius, which is 5, times itself. 78.5. Percent what? 78.5 meters squared. Then we have the lateral surface. The lateral surface. The lateral surface is going to be described as area equals pi radius times the side length. So we have area equals pi radius times the side length. That comes out to be pi radius side length. Pi radius side length. It's right here. It's right there. Yep, it's a lowercase cursive L. Shh. Michael, please be quiet. I've been hearing from the same people that are punching their calculators. I want to hear somebody else that's been putting in the work. What do we got? What do we got, Bella? 204.1 meters squared. Do I have somebody to back that up? Yes? Okay, seconded. So, good. Now we add those two up. 204.1 plus 78.5 meters squared. Yeah. So the surface area of that cone is 282.5 meters squared. 0.6 meters squared. Your homework's just like those two. Okay, questions right to left. Yes, sir. Shh, I can't hear you. Stop. The what? What is the lateral surface? The lateral surface is the length of this side. So if you were to chop a cone in half, okay, just imagine a megaphone like that. If you were to chop it in half, right through the middle, it's how long it is on the side. So it's that length. Yep, it's the length of this, and for my millions of YouTube fans out there, what I'm doing is I'm wearing a dunce hat. No. It's this here. It's that length. Yeah, I'm recording. I hope so, because I don't want to redo this. And that's all she wrote. I don't know, it's an old man.